we're doing 7.5, and we're just expanding. And I'm just going to show you a quick, simple few ways to expand. Now, if we ever just write log of like 10, we know that this is base 10. It's assumed you don't have to write it. And you can expand this to log base 10 of 2 times 5, which would expand with the addition one of log of 2 plus log of 5. But you could also say log base 10 could also be log of 20 divided by 2, which is log of 20 minus log of 2. Just saying, you can expand it. Or, you know, there's just different ways to expand. Using the knowledge of what 10 is. 10 is 2 times 5, 10 is 20 divided by 2. So we can do these things. But anytime you have log of 10, what's that going to equal? If we set this equal to y and bring this under here, it's 10 equals 10 to the y. So remember, this is 1, so y is just going to equal 1. So the whole thing, log base 10 of 10 equals 1. Anytime your base here and the number it's with are the same, the answer is always 1. So we can say log, sorry, my pen stopped. Completely stopped. Hold on. It's just tracing this. Okay, let's try again. I'm going to erase this. Had some issues. So if we had log base 2 of 2, that would equal 1. If you had log base 5 of 5, that would equal 1. Even if you had log base x of x equals 1. When the base and the number are the same, it's always going to equal 1. Just the fact I need you to know. All right, so here are a couple problems, and we are asked to condense this. And we're going to take it a piece at a time. So I'm going to take this piece first. Actually, let me go back. I'm going to take the power first, because the power out here means this log to the 2 goes, stays the same. Log to the 9 stays the same. This is a power, so it actually is going to be log 3 to the 3. Didn't leave myself enough room for this, just saying. Okay, so that means I am then going to, so I just made more room for myself. So, okay, so we have log of 2 plus. Now, 3 to the 3rd power is 27. So, honestly, I said 3 to the 3rd power, and that's how I got 27. Minus log of 9. Now, again, since there's no bases, we assume it's base 10. Now we're going to take it a piece at a time. I'm going to deal with these 2 pieces. And since they're added, I can say log of 2 times 27, because that's our rule, minus log of 9. Well, 2 times 27, 54. So log of 54 minus log of 9. Now, since they're being subtracted to condense it, it's division. Log of 54 divided by 9, right? So what's that going to be? Anybody? Log of 6. So we can take this big long term up here and simplify it into one log. So this is condensing. We're going to do this condensing next. And then we will do some expanding. All right, so patience as I enlarge this. All right, so this is natural log. Natural logs, they mean the same. They're just the natural log. It goes to the letter E. We'll explain it more later. But they have the same properties. So when you had log base m n equals log of m plus log of n, you could have had natural log of m times n. It equals the same thing. Natural log of m plus the natural log of n. So you can literally say, anytime you had a log, you can substitute a natural log and use the same exact properties. So this is going to be a power property. We're going to start there. So you're going to have the natural log of 3 plus. Now this goes to a power, natural log of x squared minus natural log of y. We always do the powers first. I just find it makes it easier. It's a shy check roll. Then I'm going to deal with these. So since they're added, it goes to multiplication. So the natural log, we'll take this 3, multiply by x squared. So 3 times x squared just looks like 3x squared. Minus natural log of y. And then subtraction goes to division. So it's 3x squared, and then divided by what? This is our answer. Just combining it, smushing it together. So that's smushing it together, condensing, making it smaller. But here, when we're dealing with 3 now, we're expanding. And the first thing I'm going to do is say, look, hey, look, there's a division. And I can remove the division with the subtraction sign. So I can say log of 7y cubed minus log of 4x squared. Okay? Now, these are being multiplied. So to get rid of multiplication, you can expand it with adding. So I can say log of 7 plus log of y to the third. Just expanded it. And then I can deal with this one. Because it has a power that can pop out in front, so there will be 3 log of y plus log of 7. So there we go. Now I'm going to go to the other side. Again, these are being subtracted. So when we subtract it, we're going to subtract the whole thing, guys. This entire quantity is being subtracted. So these are being multiplied. I'm going to have log of 4 plus log of x squared. So that's great. But then I have to deal with this because it's a power. And that power just pops out in front. So again, it's being subtracted. Sorry, I have an issue. Being subtracted. And I'm just, this log of 4 stays as it is. This is a plus sign. This 2 comes out in front. Log of x. Don't forget your brackets because this whole piece is being subtracted. And that is expanded form. So this entire thing is your expanded answer. That is the answer when we expand. All right. Evaluate using common logs. And we have changed the base formula. And we haven't talked about this yet. We're going to do this next, so we're just going to hold up, and I will do this later. So that's the end of our notes. That's the end of our notes. If you wanted to practice, let me fill in a page here. If you wanted to practice, go to page 510. Do 7 to 29 odd. Answers are in the back of the book. We're going to pick up with this tomorrow. Good luck. Somehow, things have stopped working. If you want to do things, I'm going to say it again just in case you didn't record. We are doing page 510, 7 to 29 on. You can pick up with this tomorrow, and we're going to try again tomorrow.